Good morning, friends. In the previous lecture on the determinants, we are solving some problems of exercise 4.5, and today we are solving remaining problem of that exercise. Here, that find the inverse of the each of the matrix if exists given in the question number 5 to 11. Okay, you find the inverse matrix. So the question number 10, you find the inverse matrix. Here the matrix is 1 0 3 minus 1 2 minus 2, then 2 minus 3 and 4. You find the inverse matrix. For finding the inverse matrix, first you find the mod A. Mod A, that is equal to, here this is the 1 and this 2 4s are 8 and 2 3s are 6 with negative sign, so minus 6 minus and minus 1, then you take 0 4s are 0 and 3 3s are 9 with negative sign, so it is a plus 9 and plus 2, then is the 0 into minus 2, that is a 0, and 3 2s are minus 6. So mod A, that is equal to, here 2 into 1 minus is converted into the plus into 9 plus 2 into minus 6. Therefore mod A, that is equal to 2 plus 9 minus 12. 2 6 are 12. So mod A is equal to minus 1. 9 to 11 and minus 12 1. So you can say mod A does not equal to 0. So the matrix is exist. So you can say this is the exist because it does not equal to 0. After that we find that the transpose, first we find cofactor of the matrix. Then you see here that the cofactor, first I find A11, then A12, then A13, then A21, A22, A23, then A31, A33, A32, and then A33. Okay. Then first we find the A11. Here this sign is a positive, this is the negative, this is the positive, this is the negative, this is the positive, this is the negative, this is positive, this is the negative, this is the positive. Okay, because this is a different minus 1 to the power I plus j according to this. Here you see, first I take 1, here 1, so this is equal to, here you find that if you remove first row and first column, if you remove first row and first column, then you find that the 2 2s are 4, that is equal to 4, and 2 3s are 6, it means minus 6, that is equal to minus 2. Then 8 1 2, you remove the first row and second column, so 0 4s are 0 and plus 9, bracket 0 plus 9, and that is equal to minus 9. Then A13, you remove first row and third column, then you find 0 into minus 2, that is equal to 0, and 3 2s are 6, that is a minus 6. So in the bracket that is a minus 6 and it is equal to minus 6. Same, you take the second row, this is the second row. Here you first remove the second row and at first column, then is equal to 1 4s are 4, this is a minus 4, and 2 2s are 4, it is a plus 4, that is equal to 0, because minus 4 and plus 4, that is equal to 0. Then you remove the second row and second column, so 1 4s are 4, this is equal to 1 4s are 4, that here 1 4s are 4 and 3 2s are 6, therefore this is a 1 4s are 4 and minus 3 2s are 6, so 6, therefore this is a minus 2. Next, element A 2 3, you remove second row and third column, so there 1 2s are 2, this is a minus 2, and this is the 3 1s are 3, minus 3 converted into the plus 3. So this is a plus 1 and converted into minus 1. Next, third element, that here you see A31, you take the third row, third row first column, it means minus 1 multiply 3, this is equal to 3, and 2 2s are minus 4, that is equal to minus 1. Then A32, it means you multiply 1 into minus 3, that is equal to minus 3, and then 0 into 2, that is equal to minus 0, so this is equal to 3. Then after that A33, you remove third row and third column, so 1 2s are 2, and 0 into minus 1, that is equal to 0, so that is equal to, so here you see that we find A11, A12, A13 and this. After that you take that cofactor of matrix, that is equal to here minus 2, minus 9, minus 6, 0, minus 2, minus 1 and minus 1, 3 and 2. Then you find the adjoint of ADJ of A, that is equal to transpose of that matrix. You remove row into the column, minus 2, minus 9, minus 6, then 0, minus 2, minus 1, then minus 1, 3 and 2. This is the adjoint of A. After that you find A inverse, that is equal to 1 upon mod A into adjoint of A, that is equal to 1 upon the value of mod 1, that is a minus 1 into, that is equal to minus 2, minus 9, minus 6, 0, minus 2, minus 1, minus 1, 3 and 2. Either you just wanted to change the value, then you multiply with the negative sign, so this is equal to, converted into 2, 9, 6, 0, 2, 1, 1, minus 3 and 2. This is the value of A inverse and that is the answer. Okay. I think all of you understand how we can find the A inverse, that the value of A inverse, that is equal to 296, 0 to 1, 1 minus 3 and 2. Minus 3 and this is a minus 2. Okay, because it is also the positive. Then you know how we can find the A inverse, either inverse of any matrix. Okay, so we are going to solve next another questions. Another question is also given here. Some questions are given that if you have question number here, question number 12 12 is given that here that A is equal to matrix A is equal to 3, 2, 7 and 5, and matrix B it is given that 6, 7 and 8 and 9. Then you find AB inverse. First you find the AB whole inverse, that is equal to B inverse and A inverse. Okay. Then for the solution of that question, how we can find? First I take the AB. First I take the AB. The value of AB, that AB is equal to matrix 3, 2, 7, 5, then B, that is a 6, 7, 8, 9. You just find the AB. Then I take the first row. So I take the first column, that is element. So here you see that 3 6 are 18 plus 7 7 are 49. Then another element for the second column, this is the second row. First row element of the second 3 8 are 24 plus 7 9 are 16. Next you take here that 2 6 are 12 plus 5 7 are 35. Next 2 8 are 16 and plus 5 9 are 45. Then you see 8 9, 8 plus 9 17, 1 4 5 1 6 67, 4 3 7 and 2 6 8, 5 2 7 and 3 1 4. Here 6 5 11, 4 1 5. 4 1 5 and 1 6 because 1 is carried. So this is the value of AB. First you find that the value mod AB. Mod AB, that is equal to here that you take the first row, then 67 into this is the 61, and then you take the 87 plus here second element 87 and into this is equal to 47. So this is equal to 67 divide by into 61. So 1 7 is 7, 1 6 is 6, 6 7 is 42 and 6 6 is 36, 36 and 4 40. So this is a 7 6 2 8 0 and this is a 4. So this is equal to 4087 minus 87 into 47. 7 7 are 49. 7 8 are 56. 56 plus 4 60. 4 7 are 28. 4 8 are 32 34. Then this is a 9 8 6 4 10. So 4. This is equal to minus 4089. That is equal to 8 7, this is 8 and 9, this is the minus 2. So AB, mod AB does not equal to, mod AB does not equal to 0. So it is a exist. So it is a exist. After that you find that the Aij, adjoint of J. First you find the A11. Here you take the elements A11. That is equal to, you remove the first row and first column, it is a 61. then A12. A12, you remove the first row and second column, so this is the minus 47. Then U2, A21, that is equal to, you remove the second column, first row, this is equal to 87 with negative sign, so minus 87. Then A22, that is equal to, you remove the second row and second column, so this is the 67. After that, adjoint of A is a of A, that is equal to, you take A11 and A12, it means 61 and minus 47, and then A2, this is equal to minus 87 and 67. That is the value of the adjoint of A. After that, you find that the adjoint of A, then you find that AB inverse, that is equal to 1 upon mod AB into adjoint of AB. So this is the adjoint of AB. Therefore, this is equal to adjoint of AB, that is equal to here 1 upon minus 2, and this is the determinant 61 minus 47, then minus 87, then 67. Either you remove the sign, so this is equal to, divide by also 2, so this is equal to minus 61 by 2 plus 47 by 2 and 87 by 2 and minus 67 by 2. This is the value of AB inverse. This is the value of AB inverse. You can find the value of AB inverse. After that, you can find that A inverse, B inverse and A inverse. So we are solving for the problem A inverse and B inverse. First, I find the value of A inverse and B inverse, how we can solve these questions. So that A inverse and B inverse, you see that the A inverse, that is equal to 1 upon mod A and adjoint of A. So first we find that here A11, that is equal to, here first row and first column, that is a 5, A12, that is a first row and second column, this is equal to minus 2, then A21, that is a second row and first column, that is equal to minus 7, and A22, that is equal to, here you can find that the second row and second column, so this is equal to 3. Then after that, you find that here that mod A, that is equal to 3 5s are 15 minus 7 2s are 14. So mod A, that is equal to 1. Then A inverse, that is equal to 1 upon A inverse, 1 upon mod A and adjoint of A. So 1 upon 1 adjoint of A, it means you take 5, A11, A12 minus 2, and then this is the minus 7 and 3. This is the A inverse. Okay, so this is equal to 5 minus 2, then minus 7 and 3. Then you find the B inverse. Same condition, B inverse, that is also equal to that 1 upon mod B and adjoint of B, that is equal to B inverse. Okay, so for the B inverse, first you find the mod B, that mod B, that is equal to 6 9s are 54 minus 7 8s are 56. So mod B, that is equal to minus 2. Mod B does not equal to 0, so it is also the exist. So you find B11, that is equal to 9 B12 that is equal to -7, B21 that is equal to second row first column, that is a -8, and B22 that is equal to 6. So that B inverse that is equal to 1 upon mod B and adjoint of B. Okay, I think all of you understand that 1 upon mod B that is equal to 1 upon -2, and this is a 9 minus 7, and then this is equal to -8 and 6. After that you find the value of B inverse and A inverse. So B inverse and A inverse, first I remove the sign, so this is equal to here, this is equal to 1 by 2 and bracket -9, 7 and 8 minus 6. Okay. Then B inverse that is equal to 1 by 2 -9, 7, 8 minus 6. The value of A inverse that is equal to 5 minus 7 and -2 and 3. Okay. Then you see that the value of this. Then how we can find the value of this? Here I solve. Then this is a 1 by 2. You take the first row, then first column. 9 5s are -45. Then 8 2s are 16. This is equal to -16. Then 9 7s are 63. So minus and minus plus 63. 8 3s are 24. So plus 24. Then you take the second row. Then 7 5s are 35. 6 2s are 12 plus 12. Then for the second row and second column, then 7 7s are -49 and -6 3s are 21. Okay. So you see that 1 by 2 that is a 6 5 11. This is the 11 and 1 4 5 1 6. So -61. Here 5 2 7 1 3 4. This 3 4 7 6 2 8 1 9 10. Here 1 9 10 2 4 6. Then you can see that here that is equal to 49 and 21. Second, 7 7s are 49 and 6 3s are 80. This is the 6 3s are 80, not 20. This is the 6 3s are 80. Okay. So you see 8 and 9, 17, 4 1 5 1 6. So it is a minus this. Then you see that you divide by 2 in each element. 61 divided by 2, 47 divided by 2, 87 divided by 2, minus 67 divided by 2. Okay. Then you see here that the value of AB inverse, that the value of AB inverse that is equal to B inverse and A inverse, and you can say that this is the proof. So hence this is the proof. So I think all of you understand how you can find the value of an inverse and how you can prove this value. Okay, I think all of you understand. So for the next you prove that the some other question is given here. After solving one question, the exercise has been completed. So you see the next question. Here the question is that question number 30. The question is that A is equal to the matrix 3, 1 and 1, 2. Then you find that you show that a square minus 5a and plus 7i, that is equal to 0 matrix, and find A inverse also. First you find the A square. A square, what is the value of A square? That is equal to 3, 1, 3, 1, 2, and is also equal to 3, 1, 1, 2. So the A square, that is equal to 3 3s are 9 plus 1 1s are 1. Then this is equal to 3 1s are 3 plus 1 2s are 2. And then this is equal to 1 3s are 3 plus 2 1s are 2. And this is equal to 1 1s are 1 and plus 2 2s are 4. And this is equal to 9 1 10, 3 2 5, 3 2 5 and 5. This is the A square. After that you find the value of 5a, then 5a and 7a. So A square minus 5a and plus 7i, that is equal to 0 matrix. So here A square is equal to 10, 5, 5 and 5. This is the value of A square minus 5. A means 3, 1, 1 and 2. Then 7i plus, this is the 7 identity matrix. Identity matrix 1, 0, 0, 1. There is an elements in only diagonal. This is called as the identity matrix. Okay. So 10 is the 10, 5, 5 and 5. You multiply with 5. So the 5 3s are 15, 5 1s are 5, 5 1s are 5 and 5 2s are 10. Plus this multiply by the 7, 7, 0, 0 and 7. Then this is equal to 10 minus 15. Here is a 10 minus 15, 5 minus 5 and 5 minus 5 and 5 minus 10 plus 7, 0, 0 and 7. Okay. Then you see here that so then you see that this is equal to here, that is a minus 5, then 0, then here that is equal to 0 and this is equal to minus 5 and then plus 7 0 and 0 7. So this is equal to 5 7, one is a positive, so 2 0 and this is a 0 and 2. You take 2 is common, so it is a 1 0 0 and 1. So it is converted into the identity matrix. So that is equal to identity matrix. So after that you find that the A inverse. How you can find the value of A inverse? So you find the value of A inverse as like this.